Welcome to the channel Professor Da Vinci. Hello everyone, I'm the professor and today we are going to explore the fascinating world of RSA encryption. You have probably heard of RSA, a crucial part of securing online communication. But how does it work? That's what we will unravel today. Subscribe and hit the notification bell to stay updated on tech and cybersecurity topics. So let's dive into the basics of RSA encryption. To understand RSA, let's start with the basics of encryption. Encryption is the process of turning a plain text into a scrambled text, making it more secure from prying eyes. Traditionally, we use symmetric key encryption, where the same key is used for both encryption and decryption. But it has limitations. The limitations of a symmetric key is or symmetric key crypto systems have problem of key transportation. The key is used to be transmitted to the receiving system before the actual message is to be transmitted. Every means of electronic communication is insecure, as it is impossible to guarantee that no one will be able to tap communication channels. So, the only secure way of exchanging keys would be exchanging them personally. Cannot provide digital signature that cannot be repudiated. So these are all the limitations of a symmetric key encryption. Asymmetric key cryptography, also known as public key cryptography, is the cryptographic system that uses a pair of distinct keys for encryption and decryption, a public key and a private key respectively. Here's how the asymmetric key cryptography works. The first step involves generating a key pair. This key pair consists of a public key and a private key. The public key is meant to be shared with anyone who wants to send you encrypted messages, while the private key is kept secret and known only to you. When someone wants to send your encrypted message, then they use your public key to encrypt it. They can encrypt the message or data, ensuring that only the corresponding private key can decrypt it. The encryption process scrambles the data in a way that it can only be unscrambled, meaning decrypted, using their private key. You, as the recipient, use your private key to decrypt the message. The private key efficiently reverses the encryption process, revealing the original message or data. Asymmetric key cryptography is not just about encryption, it's also used for digital signature. If you want to prove that the message or a document is authentic and hasn't been tampered with, you can use your private key to create a digital signature. The recipient can use your public key to verify the digital signature, ensuring that the message or document indeed came from you and hasn't been altered in transit. Encryption. Alice wants to send a secure message to Bob. Bob generates a key pair, public key and a private key. He shares his public key with Alice. Alice encrypts her message using Bob's private key and sends the encrypted message to Bob. Bob uses his private key to decrypt the message and reads it. Asymmetric cryptography provides security and authenticity without requiring both parties to share a common secret key. It's widely used for secure communication, data integrity, and data authentication in various applications, including secure email, web browsing, SSL, TLS, and digital signature. RSA, or Reversed Shamir Adelman, is an encryption algorithm named after the inventors Ron Rivest, Adi Shamir, and Leonard Adelman. It's the backbone of securing digital communication, including emails, web browsing, and more. Let's delve into the mathematical magic of RSA encryption. RSA uses a pair of keys, the public key, known to everyone, and the private key, kept secret by the recipient. These keys are mathematically linked. Messages are encrypted using the recipient's public key. This makes them secure during transmission. The recipient uses their private key to decrypt the message and access the original content. Key generation is the first step. It involves selecting two large prime numbers and using them to create the keys. Cryptographic keys are generated using a source of true randomness to create a secure and unique code. For symmetric key encryption, a random key of a required length is generated. For asymmetric encryption, primary numbers are randomly chosen and a key pair consisting of a public key and a private key is derived. These keys, often long sequence of bits, are generated following strict security protocols and mathematical algorithms. Key management is crucial, involving secure storage, distribution, and regular rotation to maintain the integrity and the confidentiality of data in a cryptographic system. The modulus n and the public exponent e are determined for the public key, while the private key exponent d is calculated for the private key. Mathematical explanation of RSA. As I said earlier, this public key cryptography involves two keys, public key and a private key. Messages are encrypted using public key and the messages are decrypted using the private key. So how to generate the key? The very first step of the RSA algorithm starts with the key generation. Assume we have two large prime numbers, p and q. Calculate n such a way that n equals the product of p and q. It is the modulus used both the public and private key. Compute Euler's function phi of n. Phi of n equals p minus 1 times q minus 1. So after finding the Euler's function, select a public exponent e, where e lies between 1 to phi of n, and GCD of e comma phi of n must be equal to 1. E and phi of n are coprime. Calculate the private dominant d, which is the modular multiplicative inverse of e modulus phi of n, such that d product of e equal to 1 mod of phi of n. So this is how they create the key pair. Once the key pair is generated, now the encryption process starts. Sender side. Convert the plain text, say m is the plain text, where m is infinite number from 0 to less than n. Encrypt the message using the recipient public key e comma n. E comma n is a public key pair. So ciphertext c equals m power e modulus of n. The ciphertext c is sent to the recipient. On the other hand, the recipient receives the ciphertext and the recipient uses the private key pair, meaning d comma n. D comma n is the private key pair. So he converts the ciphertext to the plain text, that is a message, with the formula m equals c power d modulus of n. And then from the message, which is an integer, then convert the integer to the plain text as an original message. Let us see a small example with some primary numbers. Suppose we want to create a RSA key pair P equal to 17 and Q equals 19. Calculate M, that's the product of P and Q. So 17 cross 19 yields 323. Compute Euler's function. P minus 1 times Q minus 1 equals 16 cross 18 equals 288. Choose a public exponent E, let us say 5. Then calculate the private exponent D such that D times 5 must be equal to 1 modulus of 288 and the D equals 173. The public key is 5, 323 and the private key is 173, 323. So this from this we have created the key pairs of public key and the private key. Now the encryption and decryption process. Sender has the public key. Obviously, this sender uses the public key to encrypt the message. So the recipient have the private key to decrypt the message. Assume the message M is 42. So the ciphertext is 42 power 5 modulus of 323. And then the answer C equals 287. This ciphertext is sent to the recipient and recipient decrypts the message using the private key. So the original message M equals 287 power 173 modulus of 323. And the recipient yields the message, gets the message M equals 42. So this is how the RSA algorithm works. This exercise demonstrates the key generation process and how RSA is used for encryption and decryption. Practicing this concept with different primary numbers and messages can enhance your understanding of RSA cryptography. RSA is secure because of the difficulty in factoring large prime numbers. Breaking it would take immense computing power. It's widely used for securing online transactions, emails, secure message, apps, and more. While RSA is strong, it's not invincible. Quantum computing poses a potential threat. In summary, RSA encryption is a cornerstone of secure online communication. Remember to subscribe Professor Da Vinci for more tech and cyber tech insights. Like and share this video to help others understand RSA encryption. Thank you for joining us today. If you have any question or idea for future video, please drop them in the comments below. Stay safe and stay curious. See you. Bye bye.